In this next section, let's now look at programming. As we discussed, there's going to be a lot of similarities to acceleration because fundamentally we're still working on linear speed skills. But in terms of the volume and intensity, there's going to be some slight differences that we want to pay attention to when we're actually programming for this. We want to go through structure, frequency, volume, intensity, methods. Again, starting with structure, we want to see how does a linear speed session focusing on absolute speed tie in with our other training components. So the first thing that we're going to go through is our pillar preparation. Again, recall, massage, stretch, activate for roughly a 10 to 15 minute session. Now, in terms of what you want to focus on, it's going to be very similar to that of acceleration, but a couple subtleties that we want to hit on. Number one, shoulder. Yes, we need flexion and extension. And oftentimes, if we see they're going side to side too much, you might need to work on the rotational qualities of the shoulder as well to make sure they actually can get into a linear type position. Thoracic spine, make sure we have adequate extension, adequate rotation. Recalling that oftentimes that arm action working side to side is a sign not only that the shoulders might lack mobility, but also that the thoracic spine might lack mobility. So let's make sure they have the freedom for that thoracic spine to interact with the hips. Number three, hip. Yes, we need flexion and extension, but oftentimes, if we're working flexion and extension, we don't want to negate the importance of the hip rotators. Sometimes having that leg locked into hip rotation, qualified by that person that tends to always stand with their toes out, if we can get better rotation, it's easier for them to get into that hip flexion. If they have to fight hip flexion constantly, we tend to see that increase the risk of some kind of overuse with compensatory hip flexors, such as the pectineus muscle. Hence the reason sometimes additional adductor work is important within this session, simply from a recovery perspective. So don't forget, the rotators are still sometimes limiters of flexion, especially at the hip. From there then, ankle dorsiflexion, always. We need that trigger to be primed and ready to go to deliver that message into the ground. And as like Franz Bosch says, it's all about the whip from the hip to deliver that message effectively. The ankle and that foot needs to be ready to go. One thing that I want to focus in on are the hamstrings. When we think about absolute speed, oftentimes we're concerned that the hamstrings are the likely or the largest risk of injury. Now, while that is the case, we want to make sure that the way we address the hamstrings within pillar prep is correct. And that oftentimes people will overstretch or think that they need to overstretch the hamstrings in a way to preserve or decrease the risk of injury of the hamstrings during absolute speed. The fact of the matter is, during both pillar preparation and movement preparation for all muscle groups, but specifically the hamstrings in the context of sprinting or absolute speed, it's important to not over-lengthen them. In fact, oftentimes we're trying to stiffen or activate the body up so it has the capacity to coil and unload. Coil and unload. If I spend too much time trying to develop hamstring length and mobility, oftentimes I can decrease the activation that I need at those high-speed running cadences. Therefore, try not to overdo your hamstring stretching. Use it as a part of your movement preparation, but don't put overemphasis on it, because while we want to prepare the body, we're not trying to develop new forms of mobility in that session. Reserve that for recovery and at the end. Focus on the things that prepare the athlete to optimize the upcoming session. Once they're done with pillar preparation, then we want to put them on the field, going through movement preparation. Again, if we're time limited, we're typically going to have a linear emphasis. So mini band is going to be linear straight ahead, and then a lot of our lateral work will be straight leg. The reason we're going to do lateral straight leg work for absolute speed is to make sure that we're activating the lateral hip musculature that actually interacts with that IT band. Recall how important that is for that IT band to load when it hits the ground and give me that vertical push I need in that optimal length tension position. Therefore, reminding the glutes, specifically that glute medius, relative to a stable trunk that needs to fire and be active is important in that mini band hip activation session. From there, dynamic stretching, again, total hip, same exact indices as we talked about in acceleration. Movement integration, linear emphasis. Typically, when we get into our movement integration for absolute speed, we'll do some of the more advanced skipping progressions, specifically the ones that require less ground contact time and more coordination in the air, such as the pop float skip. Finally, rapid response. Again, a linear type emphasis, whether it be those 2-foot pogo or 2-inch runs or 2-inch runs to sprint, all we're trying to do, low amplitude, high speed movement patterns to make sure that nervous system is ready to go. Once we come out of that rapid response or neural activation, now we're ready to go into plyometrics. This is where we will see some differences between acceleration and absolute speed. The similarities are in the direction. We still want it to be linear vertical to linear horizontal, but I would say emphasize the vertical portion. So when we're setting up our actual hurdles, we want those to be a little bit closer together. Again, think why that is. Biomechanically, the kinetics tell us that vertical motion is going to be more important. Therefore, we want to attune the athlete to overcoming gravity from the get-go. From an initiation perspective, we know how important reactive strength is to absolute speed. Therefore, the capacity to handle rapid or fast stretch shortening cycles is very important. So, focusing on counter movement, especially as a preparatory type initiation, double contact or double contact continuous, where now we see knee, less than 20-degree knee bend, very high-speed action off the ground, to inevitable drop jumps or depth jumps, where we're increasing that 2 to 3 times body weight and making sure they have the capacity to handle that vertically oriented type force. All those initiations are called for relative to absolute speed. And then finally, we'll typically use more bounding and hopping. Can you use jumping within the context of an absolute speed or prior to absolute speed, the context of a plyo session? Yes, you can, but if we're talking specificity and wanting to get specific transfer over and specific activation, our single leg patterns of hopping and bounding are going to be superior. Recall, in this session, it's only going to be about 10-15 minutes to make sure the body is ready to go now for movement skills. Within the context of our movement skill session for absolute speed, same exact overarching focus as acceleration. And that the technical portion, roughly 10 to 15 minutes. We want there to be a motor learning emphasis, introduce new drills during this time, develop coaching context so they understand your cues relative to those movements, and make sure they have high recovery. None of these sessions should turn into energy system development. And finally, we'll kick into skill application, where now they're simply actually running at various speeds in that upright linear position. 10 to 20 minutes typically in total, high intensity emphasis, as we'll soon define, full skill execution through various build-ups, and then finally high recovery is absolutely critical. In fact, high recovery and absolute speed is even more important than acceleration because it literally is asking an individual to move at the highest speeds humanly possible. When we now then start to actually talk about frequency and volume, again, you're going to find some similarities with acceleration, but some distinct differences. Number one, we typically want to do these sessions 1 to 2 times a week. Again, that session will be 45 to 60 minutes. If we talk about the minimal dose acceptable to improve absolute speed characteristics, within our Pro Football Combine preparation program, we only do a full absolute speed session once a week. Therefore, that minimal dose, once a week, if it's a full 60 minutes, going through the protocols as we'll share, is more than enough. 2 sessions is really more for an off-season type environment where you're trying to make robust changes for that person's linear speed and you have enough time from a recovery perspective for them to handle it. Volume-wise, typically the distances are 30 to 60 yards plus or minus 5 yards. Since our world in team sports and court sports is no more than typically 40 yards of sprinting distance, we'll use a 1.5 type design, and that will do no more than 1.5 the longest distance they will typically have to run. So in our case, 40 yards is that distance. 1.5 puts us at roughly 60 yards being the longest we run. During our build-ups, as we'll share, our typical distance for our elite athletes is roughly 50 yards is the longest they're going to run, but you can take it up a little farther. Repetition-wise, typically 3 to 5 repetitions of a given build-up or skill, plus or minus 2. On average, I would say 3 to 4 is probably the best place for your field sport athletes. If they don't have a lot of experience sprinting, and you take them out and have them do 5 full speed 50-yard sprints, I promise that's not going to help the average athlete out day one. Therefore, they need to have elite characteristics, even for general sporting, court and field, to handle those upper echelon repetitions. Sets-wise, typically 1 to 2, and rest. Notice, this rest time is longer than acceleration. Typically less than 6 to 8 minutes between repetitions, and upwards of 8 to 12 minutes, probably as high as 20 minutes in certain instances between those sets if you're doing more than one. A lot of these are getting pulled out of track and field and are converted for your field and court sport type athletes. From an intensity now perspective, it's the exact same conversation we had on acceleration. We have 3 different options. We have high intensity efforts, which in this case we're defining as over 95% effort, and this is perceived effort. And these being incredible for full CNS demand, therefore instigating neuromuscular changes, but also requiring complete recovery. Well, I'm recommending 48 hours. I would say as high as 72 hours is required in between true absolute speed sessions. From there, then, we can look at our moderate or medium intensities, again being at 76 to 94%. These are ambiguous type numbers. How often can you tell an athlete, I want you to go medium? They know low and they know high, which again requires us to understand that this is too slow for specific adaptation, but oftentimes too high for complete recovery. Therefore, we're fatiguing the body, but not in a manner that allows adaptation. So really, as we've discussed, medium intensity is something we want to shy away from, especially from high intensity type sprinting. Then finally, your low intensity, which is going to be that 75% or slower, which if you tell someone to do a tempo type run, that puts them in that average zone. They're going to get increased active recovery from those efforts. We see optimized motor pattern rehearsal. It's still fast enough for them to get a benefit from the pattern itself. And the physiological changes improve overall endurance. So especially from an aerobic capacity perspective, working these low intensity tempo type days are important. Therefore, in conclusion, we want those intensities, when possible, if our goal is adaptation of physiological resources, to be high intensity. And if it's more of a recovery tempo type day, maybe a shorter session, we take it into low intensity. But do not use language that tries to put the athlete in a medium intensity zone. Now let's take a look at our methods. Again, the flow chart here is going to be similar to acceleration, but now we're actually plugging in absolute speed characteristics. On the left side here, we have specificity. When we look at that specificity, it's how close that drill actually relates to the full task. So we have preparation drills at the bottom, step-over drills, as we spend a lot of time in the practical going over, second level, sled drills, which are your step-over drills, now with a little bit of load, and then inevitably full-speed free sprints, which we also call build-ups. From there, then, we can work across, working on actual intensity, that we're going to call level 1, level 2, and level 3. Now, don't think that these levels have to map to a certain time period. You can move an athlete from left to right as fast as you deem necessary as the coach or the trainer. It simply is how are they adapting to the process. At the bottom, these drills are going to be very similar to acceleration in that the wall drills will be in a vertically oriented position, as we discussed in the practical, opposed to acceleration, we're in that angled position. But the marching and the skipping patterns, with and without arms overhead, holding a med ball, or adding some kind of weight vest or dowel in terms of advancing it, those can be very similar between acceleration and absolute speed. But as you recall, we want to zone in on the skipping patterns that maximize coordination in the air, therefore leg exchange, and minimize ground contact time. But you can continue to advance these because the texture of these prep drills, within the context of movement prep, make sure you turn the car on correctly for the upcoming movement skill session. Therefore, those prep drills never go away. And when in doubt, go back to your prep drills, go back to your wall drills to help reset the system. From there, then, we have our step-over drills. And our step-over drills occur at the ankle, shin, and the knee. Literally, I'm running with a cyclical action where I step over my ankle, imagining there's a dowel there, so stepping over an ankle-high hurdle, then to shin, so a shin-high hurdle, stepping over that, to inevitably a knee-high hurdle. And we go over these in great detail in the practical. These typically occur over 10 to 20 yards and are meant to just start to instigate the postural integrity relative to the cyclical action. We can do these and advance these by having individuals put their arms overhead, either holding a medicine ball or holding some kind of a dowel. By taking the arms away, it puts greater emphasis on the trunk. By putting greater emphasis on the trunk, it has to work harder to stabilize, giving inevitably a better foundation for those legs to pull on. And then inevitably, we can add load to the system. Recall, if I'm doing step-over drills and I had a weight vest, where's that weight vest primarily loading me? It's loading me in the vertical plane. Therefore, by overloading and being able to have the ability to make that vertical exchange from a velocity perspective with additional load should cause nice adaptation. The research on weight vests, while not completely conclusive, does show that weight vests during these step-over type drills, marching and skipping, can be beneficial for absolute speed. Finally, then, we can get into our sled drills, getting a little bit closer to the actual skill of full speed running. Now, in doing so, the loading characteristics of sleds during absolute speed is vastly different than acceleration. During acceleration, based on the actual friction of the field, we discussed you being able to handle as high as 40 to potentially 50% of body weight, again, based on the friction of the field. When it comes to absolute speed, because of the technical nature and the high-speed coordination, we have to use significantly lower loads. If we look in the research, there isn't a ton, but we have a couple distinct recommendations. Number one, if you have the capacity to time your athlete during flying sprints while they're pulling a sled, we do not want to see that peak or easier average velocity drop below 10% of maximal capacity. The second that that peak power, or that average power, in this case, relative to velocity, drops below 10% of their highest capacity, we know we're actually starting to degrade the coordination itself. And we're changing the technique, thereby they spend longer on the ground, their flight characteristics are different, and therefore their leg, their motion characteristics are different. So the weight needs to be light enough not to degrade speed more than 10%. A simpler rule of thumb would be not to use a load greater than 10% of body weight. So in this case, we're talking about loads that are less than 20 pounds in most cases, which is not going to be detrimental to high-speed running. So this allows for a bit more horizontal force overload, all the while still being able to generate that vertical force capacity. Level 1 would be doing this over 30 yards to inevitably building 40 to 50 yards. Again, 50-yard sled buildups are incredibly difficult, so it would only reserve those for your elite athletes. Now, how do you perform these? Well, as you'll notice in our practical, the athlete's not going to start upright. They're actually going to have to accelerate out, bound if you would, to start to build some momentum into the sled, go through that slight transition phase, right? So steps 9, 10, and 11 if you would, and then inevitably, once they have enough momentum, they're in that upright posture, pushing it for an additional 20 to 30 yards, as high as 50 if they have elite characteristics. Then finally, we want to be able to get them off the sled and actually running full go. We'll do these full go sprints over 40 to 50, as high as 60 yards in our case for field and court sport athletes. Obviously, if we're talking track and field, it depends on their absolute distance they run on how you're going to program that. When we look at these zones, we use what's called buildups or technical buildups, where there's a buildup zone and then what we like to call a go zone, where now they're trying to be as fast as humanly possible. So let's take a little bit of time and look at level 1, 40 yards. What does that look like? Well, imagine now you have an athlete on a start line, either a 2-point start or a 3-point start. They're going to actually build up over the initial 20 yards. You have two ways you can do that. You can use a step over technical buildup or a traditional buildup. We discussed this in the practical. So what does a technical buildup look like? Well, during that first 20 yards, they would go ankle, shin, knee. With the goal is once they're stepping over knee, they've aggregated or built up enough speed where now they can really hit the gas, accelerating like a Prius opposed to a Porsche up that first 20 yards. Once they're at that 20-yard mark and they enter the go zone, the cue is very simple. Try to achieve 100% effort between 20 and 40 yards. Now, inevitably, we want them to get into a true buildup, where now when they come out of that 2 or 3-point stance, they're actually accelerating. They're building momentum in the way that they actually would need to in sprinting or on the field and court. In doing so, we see them accelerate, bound out, drive that transition up to 20 yards, and now when they do that, their goal is to go into that 20 yards at 100% full effort, trying to find, as we like to say, a new gear. Adding that to 50 yards to 60 yards improves the overall speed endurance and the capacity for that athlete to hold that speed, which is definitely important for distances longer than 40 yards. But even in developing 40-yard speed, I promise you need to help develop the athlete well beyond 40 yards so they finish the race effectively. So prep drills, step over drills, sled drills at the waist, much lower load than acceleration, and free sprint aggregate together to create, if you would, your menu of how you can actually program for absolute speed. Let's now finish this section going off two different example programs that we're going to identify as basic versus advanced, utilizing the principles from a volume intensity and a methods perspective. Let's start by looking at our basic program. Anything that is basic needs to involve an emphasis on those prep drills, which means we need to start with wall drills. Therefore, we'll work on figure 4 holds, a technical cycle, which uses 3 cues, back, up, recover, and then a single cycle, where they start and end in that figure 4 position. We go through all 3 of those in great detail during the actual practical. Going through those, it allows us to start to coach and cue the athlete, providing what we like to call coaching context. Are those drills going to make the athlete faster? No, but they're going to give you as the coach an understanding of how to coach them at slower speeds. Therefore, they can take that information in at slower speeds, making it easier for them to apply it at higher speeds. Once they can handle the wall drills, then we can go into our step over drills. If you would, the rubber to the road. We're going to go ankle, shin, and knee runs. We'll typically do this over 15 yards, 1 to 2 sets each. Now, looking at the ankle, shin, and knee runs, I talk about this in the practical, but I want to give it further focus right now. When you do these, it is critical from moment 1 that the athlete has a sense of speeding up. Oftentimes when we do these drills, it's easy to get stuck in perpetual motion, which means they're almost in place, not going anywhere, sliding their leg under their body, opposed to actually pushing the ground away and moving forward. So we use that joke, but in all seriousness, always accelerate like a Prius, not a Porsche. We don't want you bursting out of the gates, but we want you to have a sense of speeding up the entire time. So sometimes lengthening those distances to 20 yards are effective because it gives them more of a sense of speeding up. And then finally, we want to finish off with some kind of technical build-up free sprint. So we can do these out of a 3-point or a 2-point. Day one, I'd recommend out of a 2-point. And what are we going to do? 10-yard over the ankle, 10-yard over the shin, 10-yard over the knee, and then in this case, a 10-yard actual build. So it's that technical buildup versus our traditional buildup where they're actually sprinting through. This is a great way to teach absolute speed and start a session. Is this equally good for endurance athletes and people trying to improve their sprint capacities? 100%. If you're to look at any endurance athlete day one, that absolutely is the anatomy of how they're going to go through that first absolute speed session. From there then, what does something a bit more advanced look like? Well, we can do our same step over drills, but now we can add a dowel on the back. Again, by adding the dowel, we take out the arms. Arms only contribute 10%, so it's not that much of a decrease in speed. Puts the spotlight on the trunk, greater foundation for the legs to pull on. Stronger foundation for the legs to pull on means faster leg action. Therefore, we see nice adaptation, especially for the technique. Day one, I promise you, it might not be easy, but after you start doing step over drills with and without arms, especially with dowel on the shoulders, you'll start to see incredible changes in flight characteristics, and therefore force characteristics on the ground. Ankle, shin, and knee, and look at our distances here, building those up as high as 20 yards, stepping over the knee runs, giving them a sense of actually speeding up. We can then start to overload that using our waist sled drills, 20-yard build-up and 20-yard sprint. Only 1 to 2 sets of those, typically 1 to 3 repetitions. We can then inevitably get into our free sprints and just do our traditional or our true type build-up, where now we're coming out of the 3 or 2-point with the intention of actually accelerating out. We're going to use that 20-yard build zone to get as much momentum in the body as possible, and then for an additional 20 to 30-yard go zone, they're upright, blasting through, trying to find a new gear. You have options here. You can do this as it is written, waist drills first and then free sprints, but we also can complex those together. And this is true for both absolute speed as well as acceleration, where you could do 1 set of your sled-based drill and then 1 set of your free-based drill to have those contrast together and get a certain level of potentiation. So check for learning number 3. We want to now create a 30 to 45-minute intermediate level absolute speed session using 1 through 3 level type drills for any level of specificity. When you do this, pay close attention to the volume and intensities and try to be as descriptive as possible. Create this program and then contrast it with our basic and our advanced program, seeing if it falls in line from a progression perspective. It should be a little harder than the basic, but a little bit easier than the advanced. And final here, we have a couple primary conclusions that we want to use to wrap up this section. Number 1, think of synchronization. Legs should cycle underneath a vertical body position with perfectly timed front leg extension and back leg flexion in an effort to maximize overall leg frequency. Therefore, the second that back leg comes off in that toe off position, we want to immediately see that scissors type motion occur. The arms and legs need to work in a beautiful symphony, so we have those short lever arms moving forward to reposition quickly and those long lever arms moving back to hammer into the ground. The larger I can bring that hammer, the harder I can hit that nail into the ground. Number 2, big knees. Everything we said in the previous section is meant to optimize the height of the actual hip flexion of that front leg so we get that hammer down. So optimization from a timing perspective and magnitude of knee lift results in increased capacity to maximize force during stance. The height of the actual knee, therefore the amount of hip flexion in the front leg, is the primary determinant of how much force I can put in the ground, and therefore how quickly I can get off the ground and sustain my momentum. Then finally, maximize your force. Synchronization leads to better knee lift leads to bigger force. Maximizing the technique during flight allows the athlete to optimize the magnitude of force in the smallest ground contact time. We're calling that as roughly 100 milliseconds. Therefore, at the end of the day, a big force in the right time, in the right direction, is how you optimize max velocity sprinting or constant speed running for any endurance athlete.